Good, hold it. I will put on a white glove, and there is a reason for that, because I want you to be able to see my hand when we're going to make it dark, so that you will convince yourself that my hand, which is generating the wave, is hardly moving at all. For practical purposes, it's a node, and yet we get these wonderful resonance phenomenon. So I'm going to make it very dark, so that the UV will do its job, and you can see the string better. That's the only way we can make you see the string well. All right. Don't let go, under any circumstances. You will hurt me if you do that. Of course, if I let go first, then I will hurt you, but that's not my plan. Okay, so let's try to go a little bit further back. Let's try to find first the fundamental. And I'll try to find it by exciting just the right frequency with my hand. There it is. I think I got it. That's the fundamental. And look how little my hand is moving here. And you see a very large amplitude in the middle. And so these reflective waves, one runs to him, and it then comes back to me, and when it reaches me, it runs back to him again. It keeps reflecting many times. These reflective waves support each other. That's what resonance is all about. And now I'll try to find the second harmonic, so you'll see another note coming in at the middle. It's easier for you to see than for me, actually. And it's not always easy to find the... No, I'm too low frequency, I have to go up. I think I got it now. Is this it? Yeah, one extra note in the middle. Speak out up, please. Yes. Ah, that's better. Now I can hear you, thank you. There are three nodes now. My friend there is a node, I'm a node, and then there's one in the middle. If you subtract one, the 3 minus 1 is 2, then it's a second harmonic. And so now I will try to generate a very high frequency in resonance, and then you count the number of nodes, subtract one, and then you know which harmonic I was able to generate. So now I'll try to... It's not so easy, you need to get a resonance in there. No, I'm off resonance. No. Yeah. Got it. You keep counting. Keep counting. Oh, that's a super high harmonic. How many did you count? 10, do I hear 10? Do I hear 20? Actually, I counted about 27, but that's okay. All right, thank you very much. That was great that you helped me. Show you the easy relation between the frequency of the fundamental and the length of woodwind instruments. That's a 1-to-1 correlation. This is on the web, so you can download it. You don't have to copy this. And you see there that this is only for an open system. This is not for a closed open system. The numbers would be different. So if you are interested in very high frequencies, then an open system, which is only 1 centimeter long, would give you a fundamental of 17,000 hertz, which most of you can hear because you're still young. You can hear up to 20 kilohertz probably. The second harmonic you would not be able to hear. That is too high for you. An instrument which is 10 centimeters long, open, you would hear the fundamental easily, 1700 hertz, second harmonic, 3400 hertz, no problem, third harmonic, fourth harmonic, no problem. And then when you go to the very low frequencies, organ pipes that produce fundamentals in the range 20 and 30 hertz are huge in size. And you in general that holds. When you have a woodwind instrument which is tuned for low frequencies, it's big. And for high frequencies, like a flute, it's small. In a way, that's also true for string instruments. A bass, which generates low frequencies, is a big instrument. But the violin, which generates high frequencies, is a much shorter instrument. So in that sense, the reason is they have both an L here. And it's the L, of course, that is crucial in terms of the fundamental. So I can now demonstrate to you the basic idea of a flute. This is a flute. Now, the flute is this long. Low frequency. higher frequency, because it's shorter. Even higher frequency, because it's shorter. That's all it takes. Trombone. That speaks for itself, right? Make it longer, you make it shorter. I'll try. Trombone. Wind organ, 80 centimeters long, open and open on both sides. 80 centimeters, it would give me a fundamental a little higher than 170. And then it will give me a second harmonic and a third harmonic. It all depends on how fast the air is flowing by, and there will be moments that you will hear more than one harmonic. I'll try to swing it around. It's not easy for me to hit the fundamental, but I'll try that too. This is the second harmonic. Third harmonic. Fourth harmonic. Fifth harmonic. Fourth. Fundamental. This is fundamental. This is the fundamental, 212 hertz. 425 hertz. 637. 637. Thank you, thank you, thank you. Several years after this lecture, I measured the frequencies and discovered that what I believed to be the first harmonic in this lecture, in reality, was the second harmonic. So all resonance frequencies were one harmonic higher than I thought at the time. If you bang on a tuning fork or you pluck on a string, now you hear nothing. And now you hear it. It can actually be much better demonstrated with this little music box that I bought years ago in Switzerland. If I rotate this music box, it has a very romantic tune, you hear nothing. I hear a little bit. And now I put it on this box. I hear a little bit. And now I put it on this box. Unmistakable. So that's the idea of sounding boards. You have them violins, you have them on pianos, and of course the design of these sounding boards is top secret. The manufacturer is not going to tell you how they built them, because the quality of the sound, of course, is partly in the design of the sounding board. I can make you hear, and I can make you see sound. And my goal for the remaining time is to make you see and hear at the same time. I have here a microphone, which is like your eardrum, and suppose I generate 440 hertz, and I can do that with a tuning fork. So here is the amplitude of the oscillation of the membrane in the microphone, which is your eardrum, say. We amplify that, and we show you on an oscilloscope the current after amplification. And so you're going to see a signal like this. And if this is 440 hertz, so this is time. And so we are so fortunate that we have 4 musicians in our audience. Tom, who is the violinist, where is Tom? There is Tom. I hope you brought your violin. Oh, you got it there. And then we have Emily. I saw her already with the clarinet. So if you come this way, Emily. And we have Aaron. Aaron has a bassoon. You may never have seen a bassoon. A bassoon is an instrument that produces a very low tone. So the instrument is going to be very big. Bigger than Aaron. Just wait and see. It's a beauty. It's a really beautiful instrument. A flute is only this big. Ah, look at that. Beautiful, big bassoon. And then we have Fabian with a saxophone. So if you stand here, then I will first do the boring part. And what I will do is, I will show you then what a 440 hertz signal looks like produced with a tuning fork. And we'll see it there, and so I have to change the light situation substantially. So the musicians will get a little bit into the dark, but you will still be able to see them. And so I'm going to turn on now the microphone. And that's where you're going to see the signal. And when you make noise, you can hear and see yourself. 440. Boring, and no signs of higher harmonics. Now Tom will try to produce 440 on his violin, or close to 440, and then look for the higher harmonics, which makes the violin characteristic. Notice that the average spacing, the repetition, is indeed the same as it was with the 440, but you saw this incredible richness of harmonics. Tom happens to be also an excellent violin player, and so he insisted that he demonstrates that. Right, Tom? Okay, go ahead. Terrific. Emily, would you mind producing something that comes close to 440 hertz? Come a little close to the microphone. Notice the big difference with the violin. Violin has many, many higher harmonics. For instrument, maybe only one, maybe only the fundamental and the second harmonic. Can you try again? Now you have more, now you have more. Now Emily did not insist that she wanted to play, but I did. So Emily, would you please? Impressive. Aaron, with his bassoon, he ordered a special chair because he says, look, with an instrument so big, L is so large, it's heavy. Clearly a bass, which produces low frequencies, is heavier than a violin, and the same is true with woodwind instruments. Aaron, could you try something close to 440? Bizarre instrument, isn't it? You see a weird combination of probably fundamental and second harmonic. Aaron, would you mind showing some of your expertise? This is a wonderful instrument. You don't see them too often, do you? last but not least, we have a saxophone, Fabian. Now you may have to stand a long distance from this microphone because these instruments make a hell of a lot of noise, don't they? So give it a shot and try 440 or come close to that. Doesn't have to be exact. Interesting. Also, you see several higher harmonics. It's hard to tell which. So would you mind playing something real hot?
Well, it really doesn't sound like Walter Lewin anymore, does it? I'll see you Friday. All the best.
That you will say, that's really not Walter Lewin anymore. There's only one problem with helium, and that is there's no oxygen in helium. And that is also very noticeable for me. And yet, I really have to fill my lungs with helium all the way, and so I will be for a while without oxygen, and so you may catch two birds with one stone. You may hear strange frequency and you see me on the floor. So I'll really try not to fall on the floor then. Okay, there we go.
Well, it really doesn't sound like Walter Lewin anymore, does it? I'll see you Friday. All the best.
Nothing is changing in my system except for V. And so the frequency will go up, and that will be noticeable. And in fact, chances are